In our notes today, we are going to be talking about perpendicular bisectors. So before we start, I want to break up the word perpendicular bisectors. We know that perpendicular means to create a right angle. We know that when lines are perpendicular, they create right angles. Bisector is to cut in half. So from the name of this unit, or from this lesson, we know that we're talking about right angles because of the first word, perpendicular, and we're talking about cutting things in half because of the second word, bisectors. So to the left, you will see that we have a picture of a perpendicular bisector. We have line AB and line CD. And in our given, it's saying line CD is perpendicular to AB. Therefore, this is our perpendicular bisector. Line CD is the line bisecting AB. So if we wanted to say this in words, we'd say line CD is perpendicular and bisecting line AB. So when this happens, there's a few things we can say about the angles and the line segments. We'll start with the angles. You'll see that we already have one of our angles labeled as a right angle. When one line is perpendicular to another, it creates a 90-degree angle. So we can say the measure of angle CDB is equal to 90 degrees because we know that this is perpendicular to this line and also because of the image, the little box. Now because AB is a line itself, we know that there's 180 degrees in a line. Therefore, if this is 90 degrees, this also has to be 90 degrees because this is a line and also because CD is a perpendicular bisector to AB. So the measure of angle CDA is also 90 degrees. So you can always conclude that the two angles created from perpendicular bisectors are right angles. Now for the line segments, there's a few things. We know that this is cutting AB in half. D is our midpoint, which is halfway between the two ends, A and B. If this is our midpoint, we can conclude that this line segment and this line segment are equal. We see that also because they've notated it using these two lines. These two lines mean that the segments are equal. So if the entire line segment, AB, is 10, which is notated down here, we can say that this has to be equal to this. Therefore, we can cut 10 in half. This is 5, and this is 5. They have to be the same length, and because the entire length is 10, each one must be 5 since there are two. So line segment AD is equal to line segment DB, and we can say that line segment AD is equal to 5 and line segment DB is also equal to 5. Now the other thing about perpendicular bisectors is that you can measure a point on the actual line that is bisecting, and you can measure the length to this end, to one end, and the other end. and they should be equal. So if we were to use our protractor, and this is at 0, so here's 0, and we'll see that it goes all the way over to 1.5. Here's 1, and then we get to the half, 1 1/4. So it's a 1 1/4 inch, or 1.25 inches. Now, if this is in fact a perpendicular bisector, this should also be 1.25 inches. So here we have it at 0. Again, here's the blue mark that I marked for this side. You'll see that the blue mark lines up with the end point on the other side of this line segment. Therefore, this is the same length. So this is 1.25, and this is also 1.25. So you can always conclude that the point on the line that's bisecting is equidistant to the end points of the line that it is bisecting. So in other words, EA is equal to EB. EA is equal to EB. We know that EA is equal to 1.25 inches, and EB is also equal to 1.25 inches.